Hi guys, today you guys are going to be learning 10.5 tangents, and your learning target is I can use properties of tangents and I can solve problems involving circumscribed polygons. So guys, really quick before we get into this, we have two different vocab terms. We have inscribed, which we talked about a couple weeks ago. So we have inscribed. This is when a shape is inside the circle. And circumscribed is when the circle is inside the shape. Okay, so there is a difference. We have learned inscribed. We are going to learn circumscribed today. Okay, so vocab here. A tangent is a line in the same plane as a circle that intersects the circle in exactly one point. Now, we already learned about sine, cosine, and tangent, but this tangent is a little bit different. It is where a line intersects a circle at just one point. So right here, point A, this is a point of tangency. It looks a little weird because it seems like it connects in multiple spots. Technically, there's infinite points around a circle, and it's only touching at one point. So we have line AB is tangent to circle C at that point A. Segment AB and ray AB are also considered tangents. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. In each figure below, line L is a common tangent to circle F and circle G. So line L is touching each of these circles at only one point in both of these examples. Okay? So, for example, here we are going to draw common tangents. If no common tangent exists, state no common tangent. Okay? So, on this one, there actually is no common tangent. There is no way that you can draw a tangent through the center circle without passing through the other circle twice, okay? So no common tangent here. We want to make sure it's a line, and it would have to pass through twice. This one, the second one, has two options. You can either have a tangent going across this way or a tangent going across this way. Now, they're kind of hard to draw, so just do your best. So we have two options for a common tangent. Go ahead and pause me. Try that you try. Okay, hopefully somebody paused. You have a couple options on this next one. You can have a common tangent here or a common tangent here. Draw them better than me. You only want it to cross in one point. You also have a couple options for the next one. You can either have your common tangent going through or beside or beside. You only have to draw one, but these are all considered tangents. They're touching the circle at one point. And I know it's kind of weird that it has the same name as our trig stuff, but just think about it like a different thing, okay? So this says, in a plane, this theorem, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So you can check if something is tangent if you have a right angle between the radius and that line. If it is not a right angle, then it's not tangent, okay? It's just another line. So we can check this by doing Pythagorean or checking Pythagorean theorem. So we're trying to see, since KL is a radius of the circle, determine whether LM is tangent to circle K. All you have to do is make sure that this is 90 degrees by checking Pythagorean theorem. So we're going to take 20 squared plus 21 squared equals 29 squared. Maybe. So I'm going to put a question mark there. We're trying to figure out, does that actually equal? So this gives us 400 plus 441 equals 841. And you add your a squared and your b squared, you also get 841. So this checks out, making LM tangent because segment KL and LM are perpendicular. Reminder, an upside down T is perpendicular. And this is theorem for our justification, theorem 1010. That's what we used. If you didn't remember, that means perpendicular. All right, pause me again. Try the U-try. Okay, hopefully you paused. Set up Pythagorean theorem. You're trying to see if this is 90. So we have 14 squared plus 16 squared. We don't know. 21 squared. You're hoping it equals. If it doesn't, it's just not a tangent. It's not the end of the world. Go ahead and solve. So we have 196 plus 256 might equal 441. When we add, we get that this left side is equal to 452, which is not equal to 441. So this segment, although it looks like it is tangent, is not. YZ is not tangent because YZ and XY are not perpendicular. Once again, theorem 1010. Okay, so that's how you check if something is tangent, as long as you're given a triangle. Okay? Example 3, we're going to use a tangent to find missing values. So we know all radii are the same. We're going to solve using Pythagorean theorem. Some of these get a little bit tricky, and we're going to have to review some algebra. Okay? Don't freak out. Also, reminder, since we know this is tangent, we definitely have a right triangle here, meaning that this is our hypotenuse. Okay, so that's our c squared. Now, see that hypotenuse segment is actually in total x plus 16. So we're going to have to use that here in a minute. We're going to take a squared, so x squared, plus b squared, so 24 squared, equals that total c squared. Here's the tricky part. Review from algebra. Anytime you see a little squared like this, that means you write out those parentheses twice. And then we do something called foiling. So you take your first, multiply them, take your last, multiply it, or you can think double distribution. This gives you x squared plus 16x plus 16 plus 256, combine like terms. X squared plus 32x, oops, sorry, there should be an x there, plus 256. I'm just going to bring these down over here so I don't have to rewrite this. So we have x squared plus 24 times 24 is 576. And then we can solve. Guys, the solving ends up not too bad because we can subtract x squared on both sides and they cancel. So we don't end up having to do anything super crazy past this point, but you do have to be able to recall that algebra. You have to be able to do that on your next U-try as well. Okay, we divide by 32. X is just a really nice 10. So the radius of that circle is 10. All right, pause me. Try the U-try. You're going to have to do that algebra step again. Okay, here's a little bit of information. If you couldn't set it up, here's the setup. Go ahead and try to solve. Okay, there's some algebra solved out. Now we just have to finish solving. This is the easy step. All right, x ends up equaling 12. If you need to pause me to go ahead and write out this solution, do so. Okay, theorem 1011. If two segments from the same exterior point are tangent to a circle, then they are congruent. So this one's pretty cool. If you know that you have two tangent lines and they connect at a point, you know that these two are congruent. So we can solve. That's pretty nifty. We know that AC and BC are tangent to the circle, so we can find the value of x. We just know they're congruent, so you set them equal and solve. Nothing crazy here. So this gives you that x is 5. And you're done. Don't have to solve for a segment length or anything. All right, go ahead and pause me. You guys can try the U-try. Okay, so since they are both tangent to the circle, you know that these are congruent since they come to the same point. So you just set them equal, and you should have gotten that x equals 7. Okay, example 5, last type for today. Find the measures of the circumscribed polygon. So notice there's triangles around each of these circles. And here's the story. It says the round cookies are marketed in a triangular package to pique the customer's interest. If triangle QRS circumscribed about circle T, find the perimeter of triangle QRS. Okay, so we know things. All right, we know that this is 2 centimeters. And since these are all tangents, we know that this is 2 centimeters. And since this whole thing is 8 centimeters, 8 minus 2 is 6 centimeters, which is congruent to this guy. And then we know this guy is 10. So now we have all the information we need. So we're going to do 10 plus 2 plus 2 plus 6 plus 6 plus 10. Okay, that's just the addition. I went around here, 10 plus 2 plus 2 plus 6 plus 6 plus 10. And that gives us a total of 36 centimeters. This is our perimeter. Okay, pause me. You guys try this next one. Okay, so once again, you know that this is 6, which means this is 6. You have this whole length 16, so 16 and minus 6, because they both stop at that same tangent point, makes this guy 10. This guy's tangent also coming to the same point, so they are congruent. And this last one is 12. Same thing, we're finding the perimeter of the triangle, so we add them all up. 12 plus 6 plus 6 plus 10 plus 10 plus 12. Okay? Make sure, some of you might accidentally count these 16. You can do that instead of the 6 and the 10 if you want, but don't double count them. Okay? So you add these up and you should get that the perimeter is 56 centimeters. Okay. Guys, the next page in your packet, there is a worksheet. You won't have a delta on this for a while, but I would go to that worksheet. It'll be posted on Classroom to check. I would try those problems. See if you can get the answers. Make sure you understand, okay? Use your time wisely, and I will see you tomorrow.